Hello everyone, welcome back to our IGCSE Math 0580 revision session. Today we'll be doing the second half of Unit 4 Geometry. Continuing from last time, first we'll be talking about angles. In 0580 extended, you only need to know about degrees, for example 360 degree. And then a shape, for example, this is a square. This is the interior angle, and this is the exterior angle. For a square, we know that all the angles are 90 degrees. So the sum of its interior angle is 360 degrees. And all its exterior angle, because it's a line, one is 90, the other is 180 minus 90, which is also 90. So the sum of its exterior angle is also 90. And for a triangle, for example, let's say it's a equilateral. We'll have 60, 60, 60 for their interior angle, and 120, 120, 120 for its exterior angle. It doesn't matter if you're drawing the exterior angle from this line extended or this line, because it's all the same. So the sum of a triangle's interior angle is 180 degree, and the sum of its exterior angle is still 360 degree. We can notice something. So for all the shapes, its exterior angle, the sum of its exterior angle is always 360 degree. And the sum of their interior angle is the number of sides minus 2 times 180. For this formula, we can get for a triangle, there's 3 sides, which is 3 minus 2 times 180. The sum of its interior angle is 180. For a square, it's 4 minus 2, the sum is 360. For a pentagon, it's 5 minus 2, the sum is 540. And for circles, we just need to know that one cycle is 360 degrees, and that's enough. Now, since we know that the angle around the point is 360, and the angle on the line is 180, we can learn some more properties on two parallel lines and perpendicular lines. For example, in two parallel lines, if there's a line cutting them, the angle here, theta, will be the same, and the angle here, alpha, will also be the same. And we know that theta plus alpha equals 180. We can also say that here is also theta, the vertex, because here equals 180, theta plus alpha equals 180, and here this angle equals 180 minus alpha, which is theta. Thus, here is also alpha. And we know that when two lines are parallel, the intersection, their angle of intersection is 90 degrees. So this is all 90. So in this pair of parallel lines, these two angles are called alternate exterior, and they are equal. These two angles, let's say 1, 2, one is alternate exterior and 2 is alternate interior, and they are also equal. And 3, vertical, they are also equal. Then 4, same side interior, same side interior, they plus to 180. Then same side exterior, same side exterior, they also plus to 180. And last, corresponding, here, corresponding angle, they are equal. This is a G. Okay, now moving to circles. This is a circle, and this is its center. This is its radius. The radius is the distance from a point on its circumference to the center, which is equal no matter where. Radius, it's all equal. And the distance passing through the center onto 2 points on the circumference is the diameter, d. We know that the area is pi r squared and the circumference is 2 pi r. And this is a chord. A chord is just cutting the circumference. This is a chord, this is also a chord. And for chord with equal length, let's say this is chord with length x, the distance between it to the center here is equal. No matter where it is, if we have the same chord with the same length x, sorry, this is drawn a little bit out of scale, but the distance from the chord to the center will be equal. And some properties about angles in the circle you need to know. For example, here's a chord, and the angle on the circumference will be all the same. And for the same chord, the angle from the center, for example, theta, is twice the angle from the circumference. So this will be half theta. For a cyclic quadrilateral, which means that it is a quadrilateral with its vertices on the circumference of a circle, the opposite angle sum is 180. So if this is alpha, this is beta, alpha plus beta equals 180 degree. And gamma delta, gamma plus delta equals 180 degree. And since this is the diameter, if there's any kind of triangle formed on the diameter, if there's any triangle formed on the diameter with the other vertex on the circumference, the angle on the circumference will be 90. And here will be also 90. We can tell this by that theorem we've talked about, which is theta, let's say 2 theta, and the angle on the circumference is half, which is half theta. And since it's the diameter, this whole chord makes this 180 degree. Then the half is just 90. Now move on to tangent. Tangent of any shape or any curve means that the intersection is only one point. These are all tangents, and the angle of that tangent and this radius is 90 degree. So this would be also 90 degree. And if the tangent is from a point, for example point A, the length of the two tangents are equal. And now the alternate segment theory. For any cyclic triangle touching the tangent, the angle here, for example alpha, equals its opposing angle. This is also alpha. And beta here, remember it's from the tangent to this one side of the triangle, is here is also beta. This is the alternate segment theory. And the last identity is about bisector and chords. For any chords on a circle, the bisector, the perpendicular bisector to be precise, of the segment, for example AB, passes through the center. The perpendicular bisector would be like this, passing through the center. For example, another one, let's say C and D, the perpendicular bisector would be here, passing through the center. This can also be used to determine the center of a circle when given 3 with more points on the circumference. And that's it for today. Thank you for watching.